If everything went well, today should be Friday, August 7th, 2026. And I always start off my slideshows usually with just something interesting from out in the world, something that I think is kind of cool that I want you guys to see, and I think you might find it interesting too. It could be something about art or architecture, or maybe a car that I think is cool, or just some weird or wild thing that's going on out there in the world. So this is the Gateshead Millennium Bridge in Newcastle upon Tyne, England. And the third video down on your Google Classroom today will show you an interesting way that they solved how to get boats past this bridge. You can see people walk on this thing, they're almost on the water. I mean, it's really a low walking bridge, but they solved that in a really interesting way. So take a look at that video, it's just 1 minute long. There is some kind of annoying loud music that goes with it, so make sure your volume is close to all the way down. All right, and this is just a nice view of the southern tip of Manhattan in New York City. If you've ever been, you recognize this view. This is the famous Staten Island Ferry, which used to cost like 50 cents or something. Best view of New York, but now it's actually free. So you can just go right in there and they'll take you across to Staten Island, across the bay to Staten Island, and you get beautiful views of all the surrounding boroughs. Anyway, very nice scene here. All right, so this is for today. Today you should be having beef and cheese nachos, Spanish rice, lettuce and tomato, fruit milk salad bar, although there's no salad bar this year because of the whole lettuce thing, right? We don't want to get you cyclospora. And then tomorrow, which would be Monday, you're going to have a chicken patty with whole grain bun, okay? All right, remember to bring these student packets back if you have brought them back and I wasn't here. Sorry about that. Hopefully the sub collected them, and if not, just bring them back on Monday. Math fee is $5. The sub is not able to collect that more than likely, so just give that to me on Monday. Make sure you have your Chromebooks, and always charge your Chromebook overnight. We're all charging our phones. Make sure you charge your Chromebook too. All right. So this is what we're studying today. This is lesson 1-2, linearity, intercepts, and symmetry. Spoiler alert, this is pretty easy stuff. The difficulty level is dialed way back for today. You did much harder stuff than this in Algebra 1, so we're still in that review stage. Okay, so here's your mathematical standards for this particular skill, and this is what we're doing today. Okay, so this is actually, I don't always do this. I usually do a slideshow that is the same material as in your book, exactly the same examples, visuals, all that stuff, but it just looks bigger and more visual. For this particular lesson, I wanted to teach right out of your book, just for personal teacher reasons. I thought it explained it really nicely just right in the book, so I've actually cut and pasted your book into my slideshow here. So, I don't remember what page we're on, just look at lesson 1-2, okay, find 1-2. So we're going to talk about linear versus non-linear. Now, big hint here. What word do you see in the word linear? I hear you all saying it silently in your head. The word is line. A linear equation makes a line. So that's just super easy to remember, and the word is just right there. So linear equation or a linear function makes a line. Non-linear, guess what? Doesn't make a line, okay? And then we're going to talk about intercepts. Intercepts are a very easy concept. Where does it cross the x-axis? That's the x-intercept. Where does it cross the y-axis? That's the y-intercept, okay? And of course, a function can have more than one of a particular kind. And then symmetry. We're going to talk about two different types of symmetry, very easy concepts. And then also whether a function is odd or even, which is just related to the type of symmetry it has, okay? All right, so in a linear function, no variables are raised to a power other than 1, okay? So this is the basic form. You may recognize this as your slope-intercept form. Y equals mx plus b. And of course, in an actual function, the m is a number, which represents your slope, and the b is a number, which represents your y-intercept. That's why it's called slope-intercept form, because boom, there's the slope, there's the intercept. It's the y-intercept, okay? You do have to remember that. So, and notice that this, right over here, you notice this invisible math. I love the invisible math here. And let's see, which one is it? If there is no exponent on something, like if we have an x with no exponent, there is an exponent, it's just invisible. The exponent is 1, okay? 1, it's not 0. The exponent is 1. So the exponent on this x is 1, that makes it a linear equation. We don't have an x squared, and we don't just have numbers. So that makes it a linear equation. So nonlinear functions are functions that do not form lines when we graph them, okay? So determine whether it's a linear function, justify your answer. So this is example 1 in your book. Well, they're doing it algebraically. They're actually putting it in that slope-intercept form. They are distributing the division of the 3, simplifying, and then bam, there it is in that form, y equals mx plus b. It's the same form of the equation. In this case, m is 2. In this case, b is negative 5 over 3, or negative 5/3, or negative 5 divided by 3. And that is a linear. The function can be written in the form, so it is a linear function if you want to fill that in. I don't always fill these out for you, but I'm happy to help you if you want to fill those out. And then this one has an x to the 3rd, so it's automatically not a linear function. Okay? Is this a linear function? Well, it does have 2 sort of lines, rays really. They both originate at B, and one of them goes down this way, one of them goes down that way. But it's not one single line, so it's not linear. Is that a line? Yes, it's linear. Non-linear, linear. Pretty straightforward, right? Identify linear functions from a table. Okay, we've got week's earnings, and we've got week 1, 2, 3, 4, 5, and we've got the earnings. If we were to fill out this chart, we would be able to tell if we are linear or not. So there's 1, 85. Remember that in a table, a horizontal table, this is your x and y point. X and y is not always written left and right, right? This is 1, 85. So this represents the point 1, 85, okay? This is sort of your x, and this is your y. So 185 goes there, 2, 119 is gonna go there, 3, 153 is gonna go about here, 4, 187 is gonna go close to up here, 5, 221. 221 is maybe there. So there is a line that contains all the points. I haven't drawn it very well. 85 isn't there, that's 40. The interval there is 40, so we're much closer to here. So yeah, that forms a line. So that is, Michaela's function can be a linear. And this is a function written in table form. We only have the x and y values. Now you're going to learn later in the year to be able to plug this table into your calculator, and it'll give you the function that it came from. All right, use the graph to estimate. Okay, let's talk about intercepts. An x-intercept is simply the point where the function crosses the x-axis. Quick reminder, the x-axis is the horizontal one. The y-intercept is where the function crosses the y-axis. That is the vertical axis here. So example 4 in your book, where does it cross the both axes? Both of them are at 0, 0, 0. Okay? So we can say the graph intersects at the point 0, 0, therefore the x-intercept is 0, and this one is also 0, 0, and the y-intercept is 0. Okay? Let's look at this one. The graph appears to intersect the x-axis at -3, 0. Okay, that's that one. -1, 0. There's that one. And then 2, 0. There's that one. So it has x-intercepts of -3, -1, and 2. Usually when we talk about the intercept, it's just the point on the axis where it hits, but sometimes we talk about it as an ordered pair. It's the same thing. -3, 0 is the same thing as saying it has an x-intercept of -3. And then you can work out the y-intercepts. Okay, 2 more things. Symmetry. This is pretty straightforward. Line symmetry means you could put a line down the middle of the function, and it is identical. It's a mirror image on the left and right of that line. That's called line symmetry. In this case, this is example, well, this is on the learn page, but on the example, this orange dotted line is the line of symmetry. It's identical, it's every point is the same distance on left and right of it. Therefore, we have line symmetry. Point symmetry is just a little bit trickier. Point symmetry is something I call rotational symmetry, which means if we were to take this function and turn it like a propeller halfway around, 180 degrees, would it line up to itself? Would it be identical? If it would, then it has point symmetry around that point. This has point symmetry. The blue function has point symmetry because if we were to rotate it around that green line, I'm not sure where the green line comes from, but if we were to rotate it around that origin, it would line right back up to itself. This also has to do with what type of function it is, even or odd. This is an even function, okay? It's identical on the left and right of this line. A function with line symmetry is an even function. A function with point symmetry is an odd function, okay? It's an odd function. I'll talk more about that in just a second. So, even and odd. Here's our even and odd. This is right out of your book. For every x in the domain of f, this is our function. For every x, the negative x gives the same value, okay? So let's talk a little bit more about that. I wish they would put numbers in here. So let's say that's 1, and 2, and 3, and 4. 1, and 2, and 3, and 4. Okay, so the 3 corresponds to, let's call this 3, we don't know what the function is, so I'm making this up. Let's say that's 3, 8, okay? Then if it's an even function, a negative 3 should give the same y value. And we see that it does. It lines up left and right. So that is called an even function. For every x in the domain, the negative value gives the same value as a y value, or the value of the function. Okay? That 8 is the same. Now, conversely, an odd function which has point symmetry or rotational symmetry, every x value that gives a corresponding y value. So let's call this point right here, let's say that's 1, 3, all right? 1, 3, that point on that line right there is 1, 3. Then the negative x value gives us, as a result, the negative y value, okay? Negative x gives us the negative y. So negative 1 then is going to give us negative 3. Negative 1, negative 3. So this relationship shows that it's an odd function. This relationship shows it's an even function. Okay? All right, and that's the whole lesson. Let me do a couple examples here real quick. Let me see if I have some. No, I don't have any in the book. So I'll do just a couple quick examples of this type of symmetry. A line always has rotational or point symmetry. A line always has point symmetry, so if I were to turn this thing around that 180 degrees, that would be the point of rotation. Is it odd or even? I'll have to come back to you on that one. It should be odd since it has point symmetry, but it's point symmetry around a point that's not the origin. So it might have point symmetry. I don't think it has point symmetry because positive 1, that's 1, 1, 2, 3, 4. That's 1, 4. Negative 1 gives us 1, negative 1, negative 2. So that does not give us an odd relationship, an odd function. Okay, and this one, there's our function right there. This is what the graph looks like. It clearly has line symmetry. It's identical around that line. This one is neither. There's no point at which I could rotate it 180 degrees because it would all point down at that point. And there's no vertical line. This one, however, probably, it's a little hard to tell, but it probably has rotational symmetry in that that point and that point are the negative x, when we change the value of it, it's just the same on both sides, except one's positive and one's negative. That's a little harder to explain. All right, so I think I've done everything that you need for this chapter. Today's assignment is posted already on Google Classroom, and this is it. 19 through 20, page 1922, 1 through 39, all, skip number 37. 37 is just a little whacked out, okay? This will be due tomorrow or Monday. All right, thank you for your attention, and we will see you guys on Monday.